Title: AGI is closer than we think, and it will change everything. The AI you use today feels intelligent. It writes essays, generates images, solves math problems, writes code. But according to many experts, this is not real intelligence. It's narrow intelligence. And that distinction matters because something much bigger may be coming. Artificial General Intelligence, AGI. And if AGI arrives, it won't just improve technology, it will redefine what intelligence means. Let's start with clarity. Today's AI systems are specialists. They perform specific tasks extremely well. AlphaGo plays Go. Language models generate text. Vision systems detect objects. Self-driving systems navigate roads. But none of them can seamlessly transfer knowledge across domains the way humans can. Humans are generalists. We learn new skills, adapt to new environments, solve unfamiliar problems. AGI aims to replicate that flexibility. An AI that can reason, learn, adapt, and operate across domains, not just in one. For decades, most researchers believed AGI was distant, possibly impossible. But over the past few years, that consensus has shifted. Why? 3 major developments. First, extended reasoning. Early AI models simply predicted the next word. Now, models use multi-step reasoning techniques, often called chain-of-thought reasoning. Instead of responding instantly, they break problems into steps. They simulate structured thinking. This is critical because complex intelligence requires sustained reasoning, not fast guessing. For the first time, AI systems are capable of thinking longer before answering. That changes the trajectory. Second, scale and emergence. Modern AI models contain hundreds of billions, even trillions of parameters. As models grow, something unexpected happens. They begin to display abilities that were never explicitly programmed. This is known as emergent behavior. In biology, a single neuron cannot think, but billions together create consciousness. Similarly, AI systems at scale begin to show new properties. Some researchers speculate that once model complexity approaches the human brain's estimated 100 trillion synaptic connections, entirely new capabilities could appear. We don't fully understand why this happens. That uncertainty is both exciting and concerning. Third, synthetic data and world modeling. AI systems are beginning to generate their own training data. They learn in simulated environments. They experiment inside virtual worlds. We are moving beyond large language models toward large world models. Instead of predicting text, future AI systems may simulate physical environments, economic systems, scientific experiments, entire realities. When an AI can create and test scenarios within its own simulated universe, its learning capacity expands dramatically. That is a major step toward AGI. So how would we know if AGI has arrived? One strong indicator would be this. If an AI can solve entirely new, unfamiliar problems across domains, problems its creators cannot solve without being explicitly trained for them. For example, if you gave it early 20th century physics knowledge and it independently derived Einstein's theory of relativity, if it invented new mathematics, if it designed experiments and refined theories autonomously, that's no longer narrow intelligence. That's general intelligence. And here is where things accelerate. AGI may not remain stable. It could quickly become ASI, artificial superintelligence. Why? Because an AGI capable of software development could improve its own architecture. It could design better versions of itself. It could optimize its own learning algorithms. If you compress the intellectual capacity of millions of human researchers into a digital system operating at machine speed, development cycles shrink dramatically. What takes humans decades could take the system months or less. This feedback loop is often called the intelligence explosion. Now let's examine the implications. First, scientific acceleration. AGI could solve complex scientific problems at unprecedented speed. Fusion energy, drug discovery, climate modeling, advanced materials. If it unlocks cheap, clean energy, global scarcity changes fundamentally. The upside potential is extraordinary. Second, labor transformation. If AGI can perform cognitive work as well as or better than humans, then knowledge professions are no longer protected. Law, medicine, engineering, finance, programming, research. This would not just automate manual labor, it would automate cognition itself. That forces a fundamental question. What is human value in a world where intelligence is abundant? Third, information instability. AI can already generate realistic text, video, and audio. As systems improve, distinguishing real from synthetic may become nearly impossible. Truth may become socially defined, rather than empirically verified, trust may become the most valuable resource. This is not a distant possibility. It has already begun. Fourth, alignment and control. Perhaps the most serious challenge. Can we reliably control a system more intelligent than we are? The alignment problem asks whether advanced AI systems can remain compatible with human values. But human values are complex and often contradictory. Defining them precisely is difficult. Ensuring that a superintelligent system interprets them correctly is even harder. The risk is not necessarily malicious AI, it's misaligned optimization at scale. A system pursuing a goal that we defined imperfectly, but executing it flawlessly. Where are we now? We appear to be transitioning from Stage 1, blurred reality, where synthetic and real content mix, towards Stage 2, economic disruption, where labor structures shift. AGI would accelerate both transitions. Is AGI inevitable? 5 years ago, many researchers believed it was unrealistic. Today, almost none claim it is impossible. The debate is no longer if, it is when. Some estimate 5 years, others 10. Few believe more than 20. That compression of timelines is historically unprecedented. And there is one more important shift. Children born today will grow up with AI as a normal presence. For them, AGI will not feel revolutionary. It will feel ambient, just as electricity feels natural to us. From their perspective, we may be transitional humans, adults, from a pre-general intelligence era. So what should we focus on? Not fear, not blind optimism, preparation, governance structures that evolve alongside AI capability, economic systems resilient to labor disruption, education systems focused on adaptability and judgment rather than static skills. Because if intelligence becomes abundant, human differentiation must shift toward meaning, ethics, and purpose. AGI could become humanity's greatest amplifier or its greatest destabilizer. What makes this moment unique is not science fiction, it's engineering, and the pace is accelerating. The future of intelligence may not belong solely to humans, but the decisions made in this decade will determine whether that future is cooperative or chaotic, and that window for decision-making is narrowing.